Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about how to prepare a buffer, or at least the buffer that is or how to choose what acids to use for the buffer for the pH that you want. And so in this example we're given 4 acids to choose from, and we're being asked which acid do you choose with its sodium salt to make a buffer that that has a pH of 4.25. So that's the pH that we want for our buffer. And then once we choose our best choice or make our best choice, they want us to calculate the ratio of the base to the acid. So the first thing we need to do is choose the best acid for the buffer. And so since the buffer we are asked for, the pH should have a pH of 4.25, the best acid that we want to use is the one that's closest to that pH. So if we look here, we want the pKa of the acid that we use for the buffer to be closest to the pH that we want for the buffer. So of these 4, the pKa 3.74 is the closest to 4.25. So this acid here, formic acid, would be the choice, the best choice for making this buffer. So now that we know what the best choice is, they are asking us to find the ratio of the base to the acid. And so you can do that by simply using the Henderson-Hasselbalch equation. So here we have pH is equal to the pKa plus the log of the concentration of the base over the concentration of the acid. And so all we need to do is solve for this. So we have the Ka, we have the pH. pH is 4.25 is equal to, and the Ka is 3.74 plus the log of the concentration of base over the concentration of the acid. And so we subtract both sides. So subtracting both sides, we get 0.99. Okay, or I'm sorry, 0.51, sorry. So we get 0.51, and that's going to equal to the log of the base, the concentration of the base over the concentration of the acid. And now all we need to do is undo the log. So we're going to raise everything to the base 10. So 10 to 0.51 is equal to 10 to the log of the concentration of the base over the concentration of the acid. And so because this is log base 10, these are going to cancel each other out. So that becomes 10 to the power of 0.51 is equal to the base, the concentration of the base over the concentration of the acid, so that ratio. So all we need to do is calculate that value, and that is going to be equal to 3.24. So 3.24 is the ratio of the base to the acid. That's the ratio of base to acid that we want. And so you can do that by measuring out the mass, figuring out what concentrations you need, what mass you need of your base and your salt, or your acid and your salt, and then you can figure out the concentrations you need given whatever volume you're shooting for. I hope this is helpful. I hope you like this video. If you like this video, please like, share, subscribe, hit the notification bell, make sure you make a comment in the comment section, and thank you for joining me. I'll see you next time.